So hello everybody, my name is Vlad, for those that don't know me yet. And today I'm going to talk about decorators. So before we're doing the technical stuff, let's talk about the @ sign. Recently I'm trying to not take things for granted. So when I encounter something that I don't know, I'm trying to read about it. And the @ sign is something that I'm taking for granted, that I'm using a lot, and I know what its origins. So basically the first time that the @ sign was found in some scripts or some writings is in 3045 in some Greek writings, religious writings, and it's every amen word started with an @ sign. So if you are thinking when it was first shown, it's in this year. The first time it appeared on a keyboard was at 8089, but we just started using it heavily when the email address was introduced in the 70s. So what are decorators? So I will read it through. Decorators enable the separation of cross-cutting concerns by adding additional behaviors to existing code without modifying the code itself. So instead of me trying to paraphrase it, I just show you an example that I think that you are all of you familiar with. So this is a component decorator that's coming from the Angular framework, and it decorates this app component class. So basically what it do, it provides the decorator, we're providing it with 3 attributes: the selector, the style URLs, and the template URL. And I will try to simplify probably the process that's going on behind the scenes in the Angular framework, but what it states to Angular, hey, when you will see in your template this awesome root tag, please apply this or bind this instance of this class to this template. And this is the place where all the magic happens. So as I said, this is a class decorator. So decorators are being used in many languages and also in JavaScript, but it's not yet in production. Currently, decorators are in the 2nd stage of the TC39 proposal list. So you won't find it in any browser or any node environment. We are using some transpilers like TypeScript or Bubble in order to use it already. So yeah, TypeScript implemented it already when it wasn't stage 0 in the proposal list. All right. JavaScript or TypeScript decorators can be applied on classes, methods, properties, accessors. Accessors are getters and setters, and parameters. So let's do some motivation. So as you know, Fibonacci is everywhere, and it's also in these slides. And for those who don't know what is Fibonacci, Fibonacci is a recursive series in which every value is the sum of the 2 values before it. So if I will take the 5th index, its value is 5, and we can calculate it by summing the 3rd index and the 2nd index, which provides us 5. So let's try to write this function in JavaScript. So this is the Fibo function. What it does, it receives an index and returns a Fibonacci value, the value at this index. So we can see here that we are checking if the index is 1 or 2. If it's 1 or 2, we're returning 1. This is the base values of the series. If not, we are calculating the value of the i-1 index and the i-2 index, and we just summarize them. As you probably know, this is very not inefficient. Its complexity is exponential complexity. And we probably can improve by providing some cache. This is one solution. There are many solutions. I want to use this one. So we will introduce here a cache, which has already set to it 2 values. One, the 1st index, and the 2nd one, which are equivalent to 1. And what we do, we check if the value is already in the cache. We are immediately returning the value in the cache. If not, we are doing the calculation and putting it into the cache. So what we do here, it's basically that the left hand of the sum is being calculated down the recursion line but the right side is never being calculated because it's immediately returned from the cache. So instead of having exponential complexity, we have linear complexity of the calculation. Of course, we're paying here with the memory. So wouldn't it be nice just to keep the method as it is, because it's much more cleaner, and just add a small decorator to it, which will do all the memoization and the caching that we did in the previous slide. So as I said, we will use here a decorator that's called memoize. You're probably, or maybe a few of you are familiar with from the Lodash or underscore libraries. What it does in the Lodash and the underscore library, you are provided with the method, and what it does, it caches the return value of this method, and it's doing the cache through the arguments that provided to it. So if you will call the same method twice, you will, with the same arguments, the method itself will be invoked only once because the first value will be cached. Okay, so let's see how this memoize decorator is working. So there's a lot of code here, but we will try to break it through line by line. So we are declaring here a function. Every decorator is basically a function. And here we are declaring the memoize function. We're using type system here because we're writing it with TypeScript. And the memoize decorator function receives 3 arguments. The first one is the target. The target is the class itself, where the decorated method is placed. The property name, the properties that we are decorating, or the functions that we are decorating, and the descriptor. Descriptor is an object that holds this function. On the next line, what we do, we are taking from the descriptor, we're taking the value. The value is the method itself, the original method. And what we do, we put it in a variable that's called the original method. And on the next line, we are overriding the value. We're overriding the method. This way we can intercept the original behavior and put our own. So as I said, we are taking the descriptor and overriding the original method. And what we do here, I won't linger too much on the memoize implementation, but what we do, we are from the arguments and from the property name, we are extracting some key, which will represent the method and its arguments, and we store it in some local cache. And then what we do, if the property is not in the cache, we are invoking the original method here. We're invoking the original method with the apply method and store it in the cache, and then we return the value from the cache. So if it's already in the cache, we are just returning the value. If not, we are doing the calculation, putting it into the cache. What we need to do in method decorators, we need to return the descriptor. So this way, we just took, I'll go a few slides back. We took the Fibonacci method and we added a decorator it. We didn't change any of the behavior of this method, and we now can use the same memoize decorator on other functions. So let's take another example. Let's say we have some service which has the get users method, and let's say we want to cache this value during our application. It's not changing too oftenly, and we think there will be some value to storing this value in some cache. So we can put the same decorators that we used for the Fibonacci series, we can use it here, and we are decorating it. But here's the thing. Maybe the users are changing during our runtime. So we want to add the ability to evacuate the cache also after some timeout, after some TTL. With the current implementation of the memoize decorator, we are not doing any evacuation of the cache. We're just storing it into the cache, and no one removes any values from it. So how we can do it, or how we can extend our decorator in order to be able to have this behavior? What we will use here is some design patterns that's called decorator factory. Basically, this is a method that generates decorators. So if we will take a look at the first line, instead of having the method that we had in the previous slides, now we have the memoize function receiving a TTL. TTL is the time to leave. And what it returns the decorated method that we saw in the previous slides. The only difference here is that we added this line. Sorry. We added this line, so after we putting the value into the cache, we're adding a set timeout which will delete this value from the cache after the timeout that we provided. So now we just need to add the timeout that we want to have to evacuate, to clear the cache. Anybody can see a problem with this method when we use it with promises? No. Scope. No. No, this is here. We are using it. No, there is no problem with the context. Okay, so what we are caching here are the promise itself, right? Because we have a method that returns a promise and we store the promise. This is one problem. Instead of caching the value itself, we're caching the promise. And the problem is that, let's say that when we invoking the original method, right, the promise was not resolved, it was rejected. So we are storing a rejected value. What we probably want to do is to do some try and catch here. And if the method was rejected or the response was rejected, we want to remove it out of the cache. So not everybody that uses this method would be rejected. I hope it's clear. Okay, so let's go to our next decorator, and this one is a property decorator. Let's say I have some component and I want to have the ability not to use the DOM API in order to populate some attribute with a DOM element. So here is my class and I have this element and I want to bind this property to a div which has an index, which has an ID of my div. So here is the implementation of the DOM provider decorator. As you can see, it's a factory, uses the factory pattern because it receives a selector as a parameter. And what it returns a property decorator function. Here it is. This one, because this is a property decorator, it only receives two parameters: the target, the object, is the same as that we had in the method decorator, and the property name, which is the name of the property. And instead of using what we used here, we use a descriptor. Instead of using the descriptor, we are using the object-defined property API. Basically, we're taking the class and we are overriding the property. Okay, and how we do it? We do it with the getters and setters. If you're familiar with the object-defined property API, you can override or introduce getters and setters. So here, instead of every time that you will call the element on the class or as a decorated property, instead of getting the values that it was assigned with, this getter will be invoked. And in this line, we can see that we are just getting from the document with the query selector, which is a DOM API, we are taking the element from it. So we didn't have to write it by hand, and we can use now this decorator on any element. So this is how I will do it now. So I just have an element, decorated with the DOM provider decorator, and now every time that I will access the element, I will access the actual div in the DOM. This is maybe familiar for users that are using Angular with the viewChild decorator. I believe it's much more complex, but this is probably also very similar. So let's do a short pause from coding and let's talk about the important stuff, the @sign. So as I said, I was curious about the @sign and its origins, and I also was curious why we call it, I know we are in Hebrew, we call it strudel, right, the apple pie, but how it's called in other languages. So in Afrikaans, it is a monkey tail. In Russian, it's a dog. In Bulgarian, it's a badly written letter. In Italian, it's snail. So I don't see any common ground for all those. And if you want to find any other names, you can Google it, and there are about 100 different names for the @sign. The things you find on the net. Okay, so let's talk about our next decorator, which is I call it a limiter, just an example for a class decorator. Let's say I have some classes that I don't want to create more than certain amount of instances of it. And I don't want to, of course, I don't want to have this behavior developed within this class. I want to apply this behavior to any class. So in this example, here is the A class, and I can create the first instance of it, but the second one will throw an error. So here is this, it's decorator. There is a lot of code here, and I won't explain it line by line. I just want to focus on the important stuff, because what we do here, we are overriding the constructor. So there's a lot of prototype things going on, and I want to focus just on the decorator stuff that is relevant. So here we can see that, again, this is a factory. In this code, the limiter uses the factory design pattern. We have here some counter, which will count the amount of instances that were created for this class. The decorator itself provides you with the constructor function. So we can hold the constructor method, and we can overwrite it. And that's exactly what we do on the next line. We will override the constructor. So we writing this method that the arrow points to. We call it a new constructor. On every invocation of the new call on this class, what we will do, we will increase the counter by 1, and then if the counter is higher than the limit, we will throw an exception. So again, as I said, there is a lot of prototype stuff going on, but actually what we do, we're just overriding the constructor that was provided for us. If you will see it at this line, actually we do invoke the original constructor, but we adding some logic before it. And eventually we are returning the new constructor, the one that we override. So now what we can do, we're just adding the limiter on top of the class, and we have this behavior for any class that we want. The last decorator that I want to talk about is some parameter decorator, the not null decorator. And this is probably the less powerful decorators, the parameter decorators. So let's take, for example, this create person method, and it receives a name, and I decorate it with the not null decorator. What it does, it just adds some metadata to the decorators. There is no runtime capabilities for a parameter decorator. We just can add a metadata to it, but if you will add another decorator, which is a method decorator to it, this decorator can read the metadata that this decorator added and do some stuff with it. So let's see how we are implementing the not null decorator. As you can see, it's not a factory method. It just receives the 3 parameters that every parameter decorator receives, which is the target. We are familiar with it. Also the property key. We are also familiar with it. The new one is the parameter index. So we will have here the index of the parameters that is being decorated. And we have for this implementation, we have some global object validator. Some global object validator, which we are registering to it the target, the property key, and the param index, which later can be invoked and used when we're doing the invocation of the method itself. So again, I will go one slide back. here we are adding, at this line, we are adding some metadata to some global object. And later when this function will be invoked, the validate method will be executed, and we take the metadata into consideration, and we'll check if the value is null or not, and probably throw an error if it's null. Okay, so what frameworks and libraries are already using Decorator? So of course, Angular and Nest.js, the one that we talked about a few weeks ago, TypeORM, Stencil, and also some React libraries like Mobex. They are all using decorators. And I decided to write my lib of my own, not because I don't think these are bad libraries or everybody doing different stuff. I just wanted to learn how decorators work, and this is what was my like learning practice. So I'm introduced about 10 decorators now, and I took only the one that I think that are most interesting. So I have on the first two are the memoirs and the memorize. I think we talked about them a few slides before that. What is special about these decorators they are not implemented like we seen in the first few slides. For these decorators, we can provide our own cache. If we're providing them our own cache, we can have now maybe some metrics. Maybe we have now more control about when or what we want to evacuate from the cache. So they give us such powers. I will talk about them. Just I didn't want to linger too much on the memoirs and the memoirs. I think I will talk about the other ones in the few next slides. Okay. So let's say I have some component which holds an emails list, and I have a method on it that can delete emails, but I don't want to trigger the delete immediately. I want to have some delay before that. Maybe I will change my mind and I run some undo. So I have the delay decorator for that. So what it will do, it will hold the invocation of the original method before we will actually run the original method. So if you will decorate it with a delay, the delete email will be invoked only after the time that you will provide it. Debounce, you probably all or most of you are familiar with the debounce. Again, it's something that we have in the Lodash or the underscore libraries. And let's take a look. Let's take, for example, the autocomplete scenario. Let's say I have some autocomplete, which every time that I click, I'm going to my server to fetch users by name. If on every hit of a key, we will go to our backend. What happened? Tzachi. Oh, סגר את off. יכול להיות. Sorry for that. What you see? Yeah. כן, הייתי שם? זה חזק. Okay, so as I said, if on every keystroke we will go to our server, maybe we will reduce a bad user experience on the one hand, or on the other hand, maybe we will put our server to some stress because it will receive too many requests. So what we probably want to do, we want to wait for the user to leave his keyboard for a while and only then to invoke the method. And this can be done with the debounce decorator. The other decorator that I want to talk about is the throttle decorator. Let's say that, for instance, my application produces a lot of logs in certain amount of times, and I don't want to push them all immediately to the server, and I want to like spread the invocations across the time. So I just can decorate it, my method, the log event method with the throttle decorator, and it will spread the calls. The number is the, let's say if you immediately invoked the log event 3 times, one after the other. So every second, only one request will go through.
Request per second?
Yeah, yes. Okay, so things that I didn't mention about decorators, you can do some composition of them. So you can say that a method can hold 2 decorators, right? So they both will be applied and decorate the original method. So for this example, I took the before and after for your question. The before and after decorators, what they will do, they will call the provided method before and after the invocation of the decorated method. Let's say if you want to log usage of certain methods, you can add these decorators, and you will have this log called before the original method. The one that I find most interesting is refreshable. I will try to explain it the best that I can. If you will have questions, please do ask them. So let's say I have a scenario that I want to create a user, and maybe one of the things that I need to add to it is the country. But the country release is something that maybe constantly is changing, but I don't want to, in the flow of the user creation, I don't want to fetch it. I want to have my code in the create user be synchronous as possible. So what I can do, I can put a property that's called countries and decorate it with the refreshable decorator, which receives method that returns country lists and the time and interval. So this method, the get countries, will be called every minute in this scenario and populate the countries with a list. So in the create users, I can just think as like I always have the countries in my head. I don't need to do any request to the backend in order to have it. I have it always refreshed in this property, in the countries property. So yeah, so basically these are the decorators that I find most interesting in this library. There are a few more, and I already have few ideas in my mind, but if you have any other ideas, please, I will probably share the link to the library with the slides. Please open pull requests or give any suggestions. I will be happy to add them to the library. Questions? Question about the @ sign? Okay, no questions. Yeah, yeah.
So what are the chances of the decorator to get into the JavaScript?
Yeah, so the question was, what is the chance for the decorators to be added to the JavaScript ecosystem, right? So probably very high because they are already on the stage 2 of the proposal lists, and many big companies are advocating this feature. So the chances of it not get into the language, I think, are very low, and we already see the values that it brings to the language, and we can see many other languages already using decorators and the power that it gives them. Okay, so thank you.